Hello, everybody. I tried to make a recording just, like literally just now, and apparently it didn't get the audio, so I have to re-record what I just recorded. Fortunately, I don't think it's going to take me too long, and maybe because of how I ran through it previously, maybe I'll run it through it faster this time. So, a little introduction here. So I work on, I find academic papers and standardized texts, and I find data sets, and I try to build models, and I'm in the process of publishing that work at some point after I get as much as I need to get done with finalizing the work I'm doing. So I figured today I'd go over some data models I put together not too long ago. It took me about a month and a half to do the amount of work I've done with the data modeling portion of my work, and now I'm working on some complex systems models. Let's take a look here. This is a taste of the environment that I archive a lot of information in, a lot of articles like from academic journals, data sets as well. And speaking of data sets, we're going to talk about two interesting Kaggle data sets I found. That is Kaggle food choices and the subreddit confession data that I found. And so I ended up, so basically, what's interesting about both of these data sets is they both present uh, uh, tables that provide a cross tabulation analysis type of approach. So basically, what we're doing here is we're looking at certain categories and we're trying to see how they correlate with each other. So over here, if we take we're going to go back and forth between Visual Studio Code and the Kaggle pages, but so bear with me here. So for uh, for here, we're taking a look at not all the columns. There's certain columns that piqued our interest here, which is comfort food reasons, eating changes, diet current, healthy meal, and ideal diet. And initially, I found some interesting entries that really sparked the inspiration of how I'm going to go through this data and do what seemed to be appropriately sentiment analysis. So, okay, what's interesting about sentiment analysis approach? So, let's take a look at something called the Plutchik Wheel of Emotion. So, basically, we have all these different emotion states, and we have a gradient spectrum, right? And this gradient spectrum will basically associate some kind of emotional tone value based on the word, what the word represents, and the association being made, right? So that association being made would have to do with the context in which the word, the construction of words is being used. So that's what this emotion wheel is representing here, and we can have outputs, and we can have different regions of associations mapped to one another here, and that can provide different insights. To get more into why I'm doing this analysis, in particular, I'm looking at data sets that might be able to draw correlations on eating behavior. Although it is quite interesting the lack of longitudinal data out there that exists on eating behavior and especially compulsive behavior. So I'm mainly looking at data on impulsive behavior, compulsive behavior, eating behavior. That's mainly I spent a bit of time looking for, and I figured a good. So looking at this table, sentiment analysis seemed to be a good approach, which has much to do with this emotion wheel model and mapping the different association of words and the context they're being used. And with that, we're looking at the entries here. So with food choices, there's going to be two different types of entries per column that we're concerned with, right? So the first kind of entry is going to have to deal with a list of words or phrases that have little to no association, that we're going to assume that have no association with each other. And we're going to do this average calculation based on how the words associate with each other within each iterative index of the list that we consider here, right? We're gonna look at each entry in comfort foods, right? So in terms of, okay, well, let's look at the one entry here that says cookies, popcorn, and chips, or maybe ice cream, cake, chocolate. So the comma delimiter here is going to represent what makes up the list, because these values are independently associated with each other, and we're going to make the calculations based off of, okay, we're going to take the average of each item in the list, that is each index, we go down the list, each iteration we go down the list, and then we average those values together, as opposed to if for some reason I have so this entry over here that says I usually for comfort food reasons, which says I usually only eat comfort food when I'm bored. If I am doing something, I can go for hours without ... there's interesting entries here, and so basically we have these two different types of entries, and then now with the entries where we have like a whole phrase where the words have some they have some meaning clumped together with each other, right? So they're gonna be we go back to the motion wheel, right? We think about the regions of the wheel that the associations are going to take up, right? All together, right? Because we're looking at the locality of each word, like I is over here, usually is over here, and then so on and so forth, right? We're going to look at the association of each of these words in the entry, and then we do this sentiment tonality calculation. So now if I go back to Visual Studio Code here, that's what all this stuff represents. When we go into the column, we take these columns, we go into each of the columns, and we calculate the results, right? And so I used BERT and Roberta to do this. Now the problem with Roberta is it takes a raw, it doesn't really consider the overall tone of each entry. It's going to consider the individual tone, so like a raw tone. So there's more dynamics at play when we're using BERT as opposed to Roberta. So that's what's happening with the sentiment analysis that's happening here. So let's run our code. I'm probably going to let it run a little bit, but not too much this time. Just give it some time to run. Okay. Right. So we're gonna get these outputs, right? It's gonna do this printout where it's gonna output each of the rows for the columns, right? So we got row 0, then row 1, and so on and so forth, right? And we get a nice range of values here for what it's outputting. So if you pay a little attention to what it's outputting here, get an interesting arrangement of values. Even with the Roberta, like, even though I'm not gonna get into specifically the problems with Roberta, but I will say the scoring is a bit on the high end when we compare it to to Bert. So, like for instance, if we're at row 16, Bert is giving us 0.35 da da da, and then Roberta is giving us 0.89. So there's additional noise values. There's additional noise being considered into the calculation here with this regard. But anyway, let's get in. This is gonna run for a little bit, so let me close this out. Okay. And then let's take a look at our Reddit confessions. Uh, and this is going to run pretty quick as well. Now, the problem with this one, I just realized, is it used Vader instead of Roberta. Vader is going to have some noise as well, but we still get an interesting distribution of values. Now, okay, so let's talk a little bit about Reddit confessions a bit. Let's talk about a little bit about the intuition about what's happening here. So let's take a look first at the code a little bit. So we're looking at the title, the body, the score, the number of comments. Now the score is going to be the upvotes. And if we go to, now this is the table on the Kaggle page, right? Now we're still going to do sentiment analysis. Now what's interesting to point out, what type of correlations we can make here, is we can look at the text in the title here, what the choice of words people use to make up the title of their post. And then we can also take a look here at the body and take a look at the words that make up the body of the post that they make. And then we can also draw correlations on the number of upvotes any post gets and the number of comments that they get. And maybe we can make certain postulations like, okay, well, maybe there's something interesting about posts that have a high number of upvotes might have a high number of comments, right? There might be some correlation there. Now, I didn't do much as of yet looking into that sort of insight, but that's sort of a postulation that came on my mind. Well, wasn't there something interesting here where there might be a high number of comments for a high number of upvotes, and then there might be something, it seems to be there's something edgy, when someone says something really edgy, like, I stole bird scooters and made money by selling them. We have 1,839 upvotes. And then additionally, we have 232 comments, which seems to be a high number, right? So there's, maybe something with this particular data set. And then we can go up a little bit. I saw 300. Okay, there's 308 comments, 2,421 upvotes, and then the title of the post is, I took someone's food at Panera Bread because I was hungry and had no money. And then the body of the post said, I was a extremely broke college student. I commuted to save on tuition. I had a job that I worked at, ... So it's interesting what type of posts and the body of those posts and like the number of comments, of course the number of upvotes they get as well. Okay. So, all right. So I noticed there was something interesting about the columns that had to do with the title of the post, the number of upvotes, additionally the number of comments that they got, and lastly the body of the post. So that's how I went by my analysis here. And so we ran our code, and then we get these values. Now I didn't do a whole. I need to finish up putting. I need to put a report together for this, for the analysis of these two data sets. But there's an interesting distribution here, and then I figured I'd do some basic plots. So the first plot was for title, this one's for body, and we have the score, which is of votes, and then the number of comments. Alright, so it looks like that's it. And how many minutes was that this time? 15 minutes. That's a lot better than 25 minutes. Alright, see you guys around.